Let's remember Kotlin data classes. Kotlin main So if we create an object that is instance of this main class, main, and if we will print line this object, we can see the next result. This is unreadable code main, this is name, and this is reference in JVM, Java Virtual Machine, in memory. So let's add some field. Let's give it name with a string of type, this name, and run our program again. We get this format because in this class method toString is not overridden. toString. So let's pretend return main class with name and name. Some name. Yes, some value in the name field. And if we run our program again, we can see the next result. This is the correct line, main class with value name. In this class, the toString method is need to override manual. So if we write a data class, this is main Kotlin class, and let's create a data class. Data class, some data class. And if we here create the name field with my name, Aslan. This is my name. Nice to meet you. My name is Aslan. And let's print the instance of this class without override toString method. We can see immediately the correct output, some data class and the field name with the value. This is field name of variable, and this is value of this string, of this variable. So data classes in Kotlin automatically already have overridden methods toString, toEqual, and toHash. Equals, method equals, and the hashCode method. This is the standard methods of any object. Each Kotlin object class is a subclass of any class. Any is a cosmic class for Kotlin objects. And it's open, equals, hashCode, and the toString method from any class. In Java, this cosmic superclass is a class object, and if we don't write that our superclass, for example, character superclass, is extend, we can write it extends object. But even we don't specify this fragment of code, it means that any class in Java automatically extends of object class. And here we have the same methods toString, method toString, equals, and the hashCode. And we have already overridden the toString method. It must be here, toString. So let's override other methods for equal, for example, character. Yes. Let's delete this all and create a tool wizard or even student, because we have a house, Gryffindor house, and student here, house student student Harry and Germany from Gryffindor. So let's check its equals. Germany equal Harry. Is these two objects are equal? Let's check it. False, because it has the same houses but different names. Hermione Granger and Harry Potter. Let's overwrite this. We can overwrite the method equal for this class. Equals. We must return Boolean. It's a return type of this method. So we can get some object, and we can get this implicit object of student. Okay, if this is the same, that return true. If this equal this object, so if that's right, for checking conduction we use if construction, then return true. It's very simple. So here we can have we always have some object, but if we can get object null, if we compare some really existed object with non-existent object null, then we always will return false. If we have reached this section in the program, then this means that this object is not equal to this object, and this object is not equal null. Then we can compare its object names, the names of its classes. So we can write if get class, some class, and the compare is with this object name. If they are not equal, so if they belong to different separate classes, then we must return false. Okay. So also we can invoke the method equals from objects from equal. This is the static method for checking it equals. And let's say its variations deep equal. It will check with its fields. So we can specify this, the first argument, and specify this argument from constructor and return its value. Semicolon. This method equals from student we can invoke for do these operations. Equals and just specify Harry. Here we will invoke this our logic, not from object, from students here, because we overwrite that method from superclass or in object, and we will invoke this logic. Run our program. This is a mistake. Okay, let's use, instead of deep equal, only equal. Equals. Okay, run our program. The sum field is exist null value. Stack Overflow. So let's check manually each field this way: age, name, and birthday, and house, of course. So if name from this equal this object, it will return true. This is conjunction, So it must true this and the other conditions. This also age equal object dot age conjunction object dot age or method get age. We can write this. So we must extract our student. This is object from object, and here this object hasn't the fields name and age because it's object, not student. We must cast firstly to student, semicolon, and use this variable for comparing. Name, yes, he has now has name, age, fields, age, fields, and other fields. And here, this house must match with this variable house, other student's house. And birthday, this birthday other student's birthday. Yes, so that's all. Let's check the fields. House from this, and we extract wizard. Wizard have an account also, and character name, age, birthday, wizard. This is private and we can get to account data. Let's create the account is protected, and we can get this field from wizard class, from student class, because student extends wizard is a subclass. It is subclass. And also we can write like this and get the account. This account equal other student's account of Gringos Bank number account. Okay. Run our program again. False. We can get false because it's invoked this logic. For testing, we can use object equals itself. Harry equals Harry. It must return true. Yes, it must return true. Then our program works well. And hashCode. hashCode is some integer that is derived from an object. Let's open our Kotlin object. This is some class, and this is object. From object, we can derive some hashCode. If we run our program, we can see the some int number, some integer number from this object. If this is the same object, that hashCode is equal, the same object will generate the equal hashcodes. Object 2, it's object, for example, and its hashcodes must be match the same hashcode for both objects. Yes, the same int hashcode. And if we create other object, some other object, for example, string object, some string, and this object must have other hashcode than this object. We can see object hashcode this number and other hashcode this number, and there is a difference. We can see that hashcode is from any cosmic superclass, equals hashcode and toString from any class. In Java, the same. In Java, if we override in method student the equal method, then we also must override hashCode after this method. Hashcode. And we can write the standard hashcode. House is a string, so from string we can get the hashcode from this algorithm. Int hash, and for cycle e from this house dot length. Okay. Then this is declaration of hash variable, int variable, integer, and this is initialization 31 dot hash and plus character add from this field chart, yes, and this index through all indexes, and after the cycle return hash, and to get the some int value of string fields of this object, for example. Also, we can combine next a lot of fields. We can do this algorithm for house, for name, for age, and etc. So if we manually override this method, but we can also hashcode generate for wizard and what house. So in objects, this algorithm, this method hash, say invoke erase hashcode with these values, and we can see the next implementation. Return 0, object element of 31, multiplicate result plus element hashcode of elements. This realization. Here we can see that we can specify a lot of objects. House, for example, name, age, birthday, and get this hashcode for each object of Hermione and Harry. Let's invoke. Let's print line hashcode for Harry dot hashcode, and we can see the next int value. Okay, and let's print the same hashcode for Hermione. Hermione is differ from hashcode Harry's hashcode, and let's create other the same, and Harry, and for Harry and for other let's print for other Harry and other. Run our program, and we can see the same int value because this other variable and the Harry variable refers on the same object. That's right.